slides. Yeah, that works. So, hi, my name is Daz Akbarov. My full name is Said Azizkhan, but yeah, I used to work for Western companies, and my full name is almost unpronounceable for my colleagues, so that's why I use this short nickname. I'm Uzbek. I'm from Tashkent, and I had been living in Tashkent for 30 years. And yeah, I relocated to Munich last year with Amazon. I have background in software engineering, so I used to write a lot of code, and I evolved from junior software engineer at EPAM up to lead software engineer in a bit more than 3 years. Yes, I had been working at EPAM till 2024. It was fall, maybe October, when I left EPAM and I got my offer to Amazon. Yeah, and now I am solutions architect at AWS. But before joining EPAM, I worked in power engineering. And what is it? It is electrical engineering, and I worked for a company which was in charge of operating of the whole united power system of Central Asia. And it was quite interesting job in very nice company, and I really appreciated it and I loved it. But again, the compensation was not as good as in tech, and I decided that yeah, it was right time to switch. So the first reason to switch was the compensation. The second reason was that actually I had a passion to build solutions, to code, since I was a child. Because actually, I wrote my first lines of code when I was in the eighth grade in the school, and it was Basic and then Pascal. And I used to write a lot of code during the time when I was like power engineer because I am very lazy by my nature, and I used to automate all the stuff that I could automate. So, in 2020, when COVID hit, I decided that it's time to switch to tech. I went through the course, which was free, totally free of charge. And Munira was one of the persons who mentored us in this course, and I really appreciate it as well. And after the graduation, I joined EPAM as a junior software engineer. So, that's my path, and I hope that uh, it's kind of interesting to you and maybe a bit motivating. Now I work at Amazon Web Services, and my role is pretty much technical. So what I do is I help our customers of AWS, to excel with our technologies. Let's say that some of our customers, they have some business pains. They usually do, and I listen to these pains, and then I try to figure out how can we relieve them using technologies. So I work in on this, let's say, yeah, in between of business and tech, and I really like my job right now. And as I told you, I have my background in software engineering. But why I am going to talk about AI today? The main reason is that after I joined AWS and even before when I was a part of EPAM, I spent a lot of time working with AI. And here in AWS, a lot of projects which we are doing, they are AI related, AI driven. And during the last year, I yeah, I have been like spending a lot of time to excel my skills in generative AI and in machine learning and conservative machine learning as well. And today we are going to discuss how actually to perform some external integration for our AI solutions. And the stuff which I'm going to talk about is mostly AI agents. and hopefully you know what is an AI agent. If not, that's fine. I will got to cover it. And since I work in AWS, I will be providing some examples which are backed by our technologies. So all the code snippets which I will show, they will be done on strengths agents. It is open source SDK which we developed and published as fully open source. And also some of the code snippets, they will be referring to Bedrock. It is our service, so that's kind of a disclaimer. And I will definitely share this slides deck as a PDF. So no worries if you are missing some parts of it. What's our agenda for today? We have 2 hours booked, and we have like a bit less left, but I'm sure that we will try to squeeze it into the less than 2 hours, maybe a bit more than 1 hour. And during this 1 hour, we are going to discuss why actually integration matter a lot. What is the difference between a large language model and agent? How to actually pair APIs with large language models and why we actually want to do that. How to use database with your AI solutions. How to make your AI solutions event-driven using webhooks. And we will finalize with how we actually can put all this stuff together and build viable AI agent. So let's move on and let's start with the first block. Why actually do we need integrations? And here I want to compare two like opposite stuff. First one is a bare large language model. So large language model is a machine learning model which is able to process some sequence. Usually it is a text and generate another sequence, which is again usually is a text. And fundamentally, it is just basic text generator. Yes, in 2026, we have large language models which can reason beautifully, but by its nature, large language model lives in some kind of a sealed box. It doesn't know anything like from the external context. It does know the information which it was trained on, and that's it. In opposite to that, we have agentic systems, which are basically large language models plus integrations. So in order to give large language model a way to reach out to other systems, to ways to other systems to reach into your large language model, you want to provide some tools or integration. And with these integrations, everything changes. With them, your large language model, your AI system, which leverage large language model, it is able to read your real database, or it can check some, let's say, live data. It can post to your Slack or Telegram. It can trigger when a webhook is fired, and now it is an agent. So in opposite to bare large language model, agent is able not only to answer your question, but actually to perform real actions to achieve a result. Yeah, by the way, if you do have any questions, feel free just to unmute yourself and ask your questions because I am not able to read the chat. Hopefully you will do that. If not, that means that the presentation is not interesting.
No, it's
So,
very interesting. We'll ask. I mean, I can read the questions if someone message writes them down.
great. So in agents model, it actually exists, but the model, the large language model, I mean, it is some kind of a brain, and all the integrations are everything else. The eyes to get external context, the hands to make some real world actions, the memory, and so on. All right. So, what kind of external integrations can we build for our agents? So we have some kind of a three primitive types of integrations, and these are like categories. Almost every agentic capability that you have heard, uh, they depend on one of these at least, or on multiple of these. So the first types of integrations are APIs. And as usual, we want to keep it simple, and we don't want to build some extra layers in between of our agents and external systems. And we already have APIs, and we can just give agent a capability to make the API call. So when we have tools for API integrations, usually agent picks a tool, builds a request, then sends it and waits for the response. So basically, we are still relying on the request response model, right? Right. And based on the result of the response, agent will reason further and will decide if extra usages of any tools will be required. So these types of integrations are usually synchronous. And what does it mean? That agent is waiting till the server is sending out the response. And what kind of actions can we make with this type of integration? It is usually search the web, or let's say create a Jira ticket, or any like API call under the hood. The second type of integration is database integration, and databases are actually how the agent remembers and queries your structured data, your structured state. And these types of integrations have two kind of flavors. And first flavor is dealing with your operational data, with data of your customers, your orders, your inventory, and usually you want to store this. You want to store this type of data in SQL databases. The second flavor is any knowledge that you want to feed to your agent. Let's say your internal documentation, your code, your conventions, your FAQs, and all this knowledge is usually stored in plain text, let's say, for people, because you want your human employees to be able to read this data, right? But for agents, we want it to be in a form of embeddings. And embeddings is a vector form of data, and this enables agents to perform a similarity search or semantic search. And agent is able not only to read the plain text and compare the plain text, like perform full text search, but also is able to make a semantic search. The both of these two flavors matter, and they have quite a different patterns to use. We will discuss them further as well. And the third primitive is webhooks. And they are some kind of an inverse of APIs. And instead of agent calling out to some external systems, the external system can push event to the agent. So how can we use this type of integration? Let's say your agent is some kind of a software engineer, and it can be uh, like enabled. So it is usually idle, and it can be enabled by some events like GitHub can send a webhook and on PR creation, or Stripe can fire a webhook on a payment event, and your agent will perform some, let's say, fraud investigation process, or PagerDuty will trigger the webhook on alerts and so on. So in this type of integration, your agent is not trying to reach out to an external system, but it is expecting some events to happen. And the agent receives the event and then decides what to do. And this type of integration is very important because it makes your agent autonomous, and it enables your agent to be idle and spare resources while it doesn't have any tasks, let's say. And with these types of integrations, your agent, they basically don't have to wait until the human like will steer the agent or will type some task. So some event happens, webhook fires, and your agent is working on that task. Alrighty, let's move on. And let's dive deeper into the APIs integrations. So here we are going to dive from the concept of tool use through the real code into the layers of security and so on. Okay. I think that this exact slide is one of the most important slides which you are seeing, so please pay some attention to it. And here we are going to talk about the pattern of tool use. Raise your hand if you know what is a tool use of LLM. It might be also called function calling. Fine, I'll get you covered. So tool use is some kind of a protocol or convention of large language models when a model uses to ask for things from the outside world. So basically, uh, we are providing large language model some list of tools as a part of its prompt. Each tool has four things at least: name of the tool, language description, because a large language model will read this description, schema of a parameters, and which params are required for four things for each tool. Description is very critical because large language model will decide whether to use this tool or another tool based on this description. And if we are talking about the exact tool that is listed on this slide, it is get weather. We lack of this. And if we will put, let's say, weather function as a description, it will be bad because bad give, let's say, broader description. Get current weather. You can treat the descriptions for each tool as documentation for your, let's say, junior engineers. And this description should be quite comprehensive. They should be very understandable and clear, transparent. And you have to treat a large language model which will read this description as a 5-year-old kid. Your descriptions. And when large language model wants to use a tool, it actually doesn't call a tool. It is not able because remember, it lives in a sealed box, but it will output some structured response. Typically, it is a JSON saying I want to call some tool. Let's say get weather in our case with city Tokyo. So here we will have this type of a description. Oh, sorry, output of the model. And then your harness. The harness is let's say software system which you build on top of the large language model to make it actually agentic. It will receive the structured output, and then it will parse it and then looks up the actual tools and will invoke the tool and provide the output of the tool to a large language model. The tool result in the next iteration of invocation of LLM. So LLM never executes the actual tools. It produces structured intent. Your harness does the actual work. The good news is that you don't have to write your own tool parser and tool executor, because usually when you're using some frameworks like Strengths Agents, LangGraph, OpenAI, Agents SDK, or CrewAI, we have tons of frameworks for harness building. We usually have this feature in these frameworks. And yeah, not giving LLM ability to execute a tool is not a bug. It is a security feature because we want to have a full control of the external integration of LLM, because LLMs by their nature are some kind of a black boxes, and we are not able to control them, and we are not able to understand them. And that's the reason why we want to have this middleware in between of the LLM and actual external context as a harness, which will be responsible for control, which will be quite transparent. It will log, it will keep audit trail for us. All right. How can we actually build a tool? So as I told you, harness this whole system around the agent. It is a basic software, not a basic, sometimes it is quite sophisticated, but still it is a software that we used to have as a software engineers. And we as engineers, we are responsible for writing. So here you can see the code snippet, uses strengths agents, and we have a tool for getting weather, and we have a decorate. Yeah, starting from the basics, it is a Python, and we have a decorator tool, which will convert our Python function to actual tool for large language model and agent. We have a name for this tool. It will be parsed. We have a docstring, let's say comment, which will be converted to the description. And you have to write this docstring as a documentation for your teammate. And it's good to have like use when line that helps the model decide whether to use this tool in the exact case or not. Uh, then we have very important line is a timeout. So basically we have just a request code which is forming up get request and sending it. And it's very crucial to have timeouts as well. So we have to have this timeout to be safe. And uh, yeah, why we actually do that? Because agent can call this tool multiple times. And if our external API, any downstream system is slow or it is down, uh, this request can totally block the agent, and we want to have some timeouts. Uh, and yes, then once your tool is fully defined, you're going to provide this tool to your agent and then invoke the agent with some prompt like, will I need an umbrella in Tokyo tomorrow? An agent will perform some reasoning. Then it can figure out that it needs actual weather in Tokyo for tomorrow, and it will use this get weather tool for to, in order to get the actual weather from external API. In our case, it is weather.example, but uh, overall, yeah, we have a lot of free to use weather APIs. If you want to make this tool production ready, we lack of some stuff here as well. So we definitely have to implement retry logic. Yes, our harness usually can retry for in our behalf, but on our behalf, but it's better to have this logic in the tool itself. Also, we have to have circuit breakers, and we definitely want to have structured logging. All right, let's move on.
Before we move on, I thought like there were two questions. Maybe I will read them out for you and then maybe you answer.
Yes,
Yes.
please.
So one was actually a couple of minutes ago. If almost every agentic capability reduces to APIs, databases, and webhooks, then is modern AI engineering really more about systems orchestration than model intelligence?
Hmm. Quite interesting. It is actually the both because we really depend on how how smart our large language models are, and they are becoming smarter and smarter. That's right. But we have to build solid and let's say uh, good quality harness around the large language model, and it is half of the success to have this harness. And yeah, they both matters a lot, but you cannot build a really good large language model on your behalf, but you can build good harness, and that's why I am paying a lot of attention to the harness.
Okay. And then actually the second question was, so basically harness means some constraints, guardians, right? That was kind of a question.
Harness is a software system which leverages large language model to imitate thinking process. And harness is basically an event loop which loops infinitely around the I actually have this here, right? Yeah, so some kind of a loop over these five steps. So harness gets some goal, and then it leverages large language model to actually figure out a plan to reach this goal to fulfill it. And then harness is executing this plan point by point. And on each point of the plan, harness is trying to figure out, do we need to make some tool call, then perform this tool call, appends additional context to the initial context, and then iterates over and over. And large language model actually works in request response paradigm, right? We prompt the LLM and we get an answer. And harness is converting LLM to some system which can be autonomous, which can perform real world actions.
Thank you.
Alrighty. Yeah. Authentication. Here we have four patterns that we usually use for agent integration. And the first pattern is using API keys. And this is the simplest way to build an authentication for your agent. And you will have some token in your authorization header. And you can use this type of authentication for low risk operations such as reads of some public-ish data like weather, currency rates, public knowledge bases. But it's a bad practice to use this type of authentication for anything that mutates, performs write operation. The second type is using OAuth 2.0, and here we use this type of authentication when the agent needs to act as a specific user to perform actions on behalf of specific user. Let's say I want my agent to write a draft email in Gmail in my account, so I can use this type of authentication. The user authenticates once, and agent will store a refresh token, and the agent uses this short-lived access token to access the system and refresh token to refresh the access tokens once uh, they are exhausted. And uh, this type of auth is very handy when scope matters. Let's say you want agent to read exact user's calendar, not everyone's calendars, or I don't know, if your coding agent should have access to exact personal GitHub account. One more pattern is using SigV4, and it is our AWS native type of authentication, and we use it to perform some actions in your AWS accounts by your agents. And your agents with this type of auth, it runs in a role. It is our, let's say, concept, and AWS side services trust that role. You will have no long lived secrets in your data, and this is some kind of a standard inside of AWS. And if you're going to have some agents which will work with your infra in AWS cloud, I strongly recommend you to use this type of authentication. It is built in into our SDKs. For instance, here in the code snippet, you can see Boto3, which is our Python SDK. And signed requests. So HMAC, it is a hashing, and with this type of authentication, we are using secrets. Um, so this type of auth is used where in two places. Outbound, when you are calling some sensitive APIs that need to request integrity, and inbound when your agent is receiving webhooks with some sensitive data as a payload. And in this type of authentication, we are some kind of a ciphering the request body with some secret which is shared between the requester and the server. And one more very important principle here is to pick less privilege option that works. That means that uh, always give the least required or needed privilege to your agent. Do not give any extra privileges. So if your agent needs to read some data, never make it able to write to this data. And one more very important principle is never inject user secrets into prompts, because prompt can be leaked and you will expose these secrets. You always have to pass secrets through some secure channels such as Vault, for instance, or Secrets Manager in AWS. Okay. Some of the advanced concepts which I have been talking about, like on the one of the previous slides, it is about timeouts, retries, and idempotencies. Sorry. Timeouts, I have already mentioned them, so it is quite crucial to have timeouts to avoid any blocks of our agents because we want our agent to be responsive all the time. Retries with exponential backoff, they are also very, very important because everything fails and network fails, networks fail as well, and our downstream systems fail, and we don't want our agent to be dependent on uh, retry logic implemented by large language model because it is not deterministic. So we want to have this deterministic logic of retries in the tool code. So here we have retry in Tenacity library, and you can just use the retry decorator to implement this logic, and it's actually done for you by this library. And one more critical part, if you perform retries, these are actually dangerous in cases when you write something with API call. Let's say you are posting something or you are performing update request and updating some data, and if you call these actions multiple times because of some, let's say, network glitches or because of the API throttling, you will be creating multiple instances of the same entity, or you will be updating the data like multiple times, and it's not good. And that's why we need idempotency keys. And these keys are some kind of IDs, and that's a good practice to use UUID, for instance, for idempotency keys. And uh, if you will send multiple requests with the same key, your backend will handle only one of them, and that's how you actually work, for instance, with payment systems, with Stripe, or with AWS APIs as well. Basically, every serious API supports a idempotency key. All right. What else? I told you that we actually haven't built anything extra like on top of the APIs, but I lied because we actually did. We built MCP. It is a model context protocol, and it is a standard. It is some kind of a shared language for agent integrations, like as of 2026. And the problem which MCP tries to solve is quite simple. Each agent framework had its own, let's say, tool API. Strengths tools were not compatible with LangGraph, and Crew AI, it was not able to speak to OpenAI's function call format, and it was awful. So if you wanted to build different agents with different frameworks, you couldn't share tools between them. And MCP is a standard which actually is fixing this problem. And MCP is dictating you that you write a server that exposes tools. And this server speaks with your client in a standard JSON RPC protocol. And it can speak in JSON RPC over STDIO if it works locally, or over HTTP or SSE if it is a remote MCP server. So basically, it is a protocol. It's not a code, it's not a solution. It is a protocol which dictates us how we expose tools to our agentic systems. And any agent that speaks MCP can connect to any MCP server. So MCP is some kind of a REST for agent. And MCP was developed by Anthropic, if I'm not mistaken, in 2024. Yeah, I stated it in the slide. And now it is an open source protocol. So basically, if you support MCP, you support a lot of MCP servers. And if you're building your own agent, you're building MCP client. And please build it in that way that it supports MCP servers, and you will be able to connect your agents to a lot of different external data sources. Okay, and in opposite, if you are building some new integration, you also have to wrap it in as MCP server, because in that way you will make it, let's say, reusable, and you write one tool or one set of tools, and every MCP speaking use it. What kind of MCP clients do we have? A lot of them, actually. So if you use some agents for coding, like Cloud Code, Cursor, any of them, all of them, they support MCP. And almost AI tool which you are using in 2026, it supports MCP. How actually connect MCP server to your agent if you use strengths? It is very simple. We have a construct called MCP client, and it is actually implemented in strengths library. So you basically import it, and then you can just create new instance of MCP client with type of SSE client. So here we have a remote MCP server is talking to our client over server sent events. So here we have streaming. And after that, you will be able to use this MCP within your agent. So agent will request MCP server, will send a request with list tools, and after that, it will get list of tools which are exposed by this MCP server. Okay. But what if your agent wants to talk not only to MCP servers, but you want to implement multi-agent system? For that purpose, we have another protocol. So this protocol is same style as MCP. It is JSON RPC over HTTP, but it has some kind of a different shape. And with this protocol, each agent is not exposing list of tools. It is exposing some, let's say, agent card. It is some kind of a visit card in a JSON format where agent describes its capabilities, structure of input, structure of output, and authentication requirements. And other agents are able to fetch this agent card. And if this agent, which is exposing its agent card over by A2A protocol, is useful for the task which another agent has, another agent can delegate work to this agent. So this protocol was launched in 2025 by Google, and apparently it became open source as well. And with this protocol, you can build really sophisticated multi-agent systems. And you have to distinguish between MCP and A2A. The mental model is the following. With MCP, you can give your agent some tools by MCP servers. Let's say tools to query your Postgres database or to read your GitHub repo. But with A2A, you're not giving some deterministic tools, but you're giving another agent to your agent, sub-agents, let's say. And with A2A, you are giving capability to delegate some tasks from one agent to another agent. And why actually do we have these two protocols? Aren't they opposite to each other? Mm, some kind of, but they are also complementing each other. They are solving different problems. MCP servers are tools. They are passive. They should be invoked somehow by the agent by performing this MCP tool use. They are stateless and they are dumb. A2A is for multi-agent orchestration, and A2A endpoints are agents, so they are smart. They can reason by themselves, and they have their own set of tools. Okay, what if we want to integrate our agent to some system which doesn't expose itself by API? It happens, and usually it is two types of systems. First, our tool which has no, let's say, clear documented API, such as, let's say, computer use, because your operation systems, they have APIs, but you have so many APIs in operating systems that it's easier to implement computer use. Or the same with browsers, you are able to automate your browser, some kind of, let's say, playwright, uh, but usually you want to have some another layer of abstraction on top of that. Or the second type is legacy. Usually you can have some legacy applications written in 90s or in early 2000s, and they also don't expose any APIs, and it's better to use them with computer use or with browser use if it is a web application. So, and we have two types of like using these types of integrations. First, vision-based. So vision-based computer use or browser use is basically uh, scanning your interface using computer vision to transform or to convert your interface to a form which is understandable for a large language model, and then LLM, yeah, let's say, can see a screenshot or a short video and decide click here or type this. And this type of integration works well on anything that renders pixels. And yeah, it's quite flexible. The second way to deal with these types of integrations is a code-driven. So usually it is about web applications which don't expose APIs. So in that case, we can use headless browser to integrate our agent with these types of applications, and we can use Playwright, Puppeteer, Selenium, or these types of tools. And the agent generates DOM selectors and clicks via code. It might be cheaper because you don't leverage computer vision, and it's uh, faster by its nature. Again, your agent is dealing with structured data, not only with visual data. But these types of integration, they work only when on browsers, and they breaks at the moment that, let's say, class name changes or any convention changes. And browser use integrations are quite important, and they are quite usable, but uh, you have to keep in mind that they might require a bit more of maintenance. Okay, one more type of integration that I haven't talked, and it is definitely not an API integration, it is files. But they are very important as well because I hope that I'm not exposing any secret data, but almost a half of actions which are performed by agents in AWS, they are performed with files. So let's say we have coding agent or you have some kind of a Cloud Cowork agent which deals with your files. They all deals with your local file system. They read your file system and they write files if they are allowed to. Every coding assistant, every report generation system, let's say research system, they are manipulating your file system. And this file system manipulation, it is done over the API, that's right. But they are very different from the APIs that we are used to use with our agents because these APIs they are simple because we ask something, we get answer, and it's done. But yeah, but they are stateful. They are harmful because you can just basically delete very important files. And we have three critical rules to deal with your files. First, you have to have some sandboxes for your agents. You you shouldn't allow your agent to deal with the whole file system. And if you are giving write access to your agent, please sandbox it to some exact path, and it's very important. One more rule is to block path traversal. That means that you are not allowing your agent to go to uh, like in other folders. And one more rule is if your agent is performing writes, please don't implement full replace. It's always better to use diff-based edits. And if we are talking about the code implementation, here we have safe implementation for read and write files. So safe helper is a crucial part of our defense here, and it will join requested path under the workspace root, and it will call resolve because we need to resolve symlinks and segments. And it also is in charge of checking that the resolved path is still inside the workspace, which agent is using and is sandboxed in. Anything, yeah, if agent tries to escape from this path, or any of the symlinks are pointing outside of this path, all these actions will be rejected by the safe function. And with this safe function, read file and write file tools are becoming some kind of a wrappers over the safe. And every tool which yeah, basically you have a tool, but you're calling this tool, yeah, you have a function and you're calling this function in a tool by chaining to safe. It is very crucial to have this some kind of a guardrails. All right. But what if you are dealing with cloud environments? I think that you have to work with the same safety rules in cloud environments as well. Yes, in AWS, for instance, we have some additional safety boundaries, but again, you have to have some guardrails for your agent, which is not allowing it to escape from this folder or to modify files outside the folder which it runs in. But on top of that, you have to have least privilege bucket policies, for instance, to give your agent minimal permissions to perform actions. You may use also key prefix sandboxing and always use server-side validation if you make some requests to tools on a remote server. One more type of integration. Code execution is also a tool, and it is also a very important tool because if your agent is able to run some code, it will give your agent a lot of capabilities. Uh, so before we were talking about the deterministic tools. They are some kind of a fixed code, and we as a software engineers, we should write these tools for our agent. So this get weather or make SQL query, post to Slack, whatever. These tools are written by us, and then these tools are provided to our agents. So hence we have written these tools by our hands. We tested them and we are sure that these tools are secure, for instance. But with code execution, we are making our agent very flexible. So basically, agent is able to produce code for some tool, let's say code for execution by itself, and then execute this code. And it will make your agent very flexible. So it will be able to produce tools for itself for any case, like on the flight. But is it good? Actually, it's very powerful, but we have to be very careful with this capability because usually the agent-generated code is not tested in terms of security. So we have to treat this code as insecure by default. And uh, with this type of integration, where when your agent is able to produce code and then execute it, you are able to make a lot of different tasks like you can do data analysis, you can build very fancy plots, you can debug something on the fly, and so on. But if your agent generated code, you never run this code in your main process of your agent. You create some new sandbox environment, which is ephemeral, which is created to actually invoke this part of code, and only for that. And after running this code, it should be totally destroyed. So how to implement this type of integration for your agent? Again, some piece of strengths code, and here we have a tool to run Python code. So here we are using managed sandbox by E2B, and you can create E2B sandbox and run code which is provided as an argument for this function. Very simple. And once the code is invoked and run, the result will be exposed by std_out. That's it. And in our case, sandbox, it is a must-have feature. Uh, Again, if you want to run some code uh, which is generated by large language model, you will always have to have some sandbox. And we have different types of sandboxes which are developed for you, and you are able just to use it. So we have E2B, we have different other types. Uh, if you want to create your sandboxes in AWS, you can create AWS Lambdas on the flight, and AWS Lambda works quite well for this because you can create Lambda with very strict permissions and run your code within this Lambda, and Lambda is sandboxed by its nature as well. Alrighty, we have covered first type of integration, and we are going to the second category, which is databases. And this type of integration is usually used when your agent is like it stops to ask some additional questions to gather some additional context, or it doesn't want to uh, perform real world actions, but actually agent with these types of integration, agent want to store data and persist it somewhere. And as I told you, we have two flavors of database, and let's discuss them in details. What do you think about when you hear database? Usually you think mostly about SQL, right? Like MySQL database or PostgreSQL. And these types of databases are databases with rows and columns. So we have structured data in them. And yes, agentic solutions can work with SQL databases. And in some cases, we expose SQL databases to agents. And agents need these databases, but yeah, but why? Uh, Usually they treat SQL databases as a business source of truth. Let's say you store business-related data like customers, orders, inventory, users, transactions in these databases, and agent usually is able to read this SQL database. The second type of databases that we use for agents are knowledge stores or knowledge bases. And these types of databases are usually used as long-term memory, and uh, in opposite to the structured data that we store in SQL databases, here in vector database, we store unstructured data. It can be some conversations, summaries, any embeddings created from your documentation. And yeah, we can store this data in OpenSearch or in PostgreSQL using pgvectors plugin. And we have a lot of more vector databases actually. For instance, we have S3 vectors in AWS or Pinecone. And with this type of databases, agent is not querying by some keys. It's not querying structured data. It queries by meaning, and it's performing some similarity search. And yeah, these two types, they are not interchangeable. If your agent works with SQL database, it doesn't mean that your agent doesn't need vector database. They are, again, complementing each other. So if you want to deal with your business data, such as, let's say, orders, don't put them into the vector database because you don't need to make similarity search over the orders, right? And the same, if you want to have your internal documentation, such as standard operations procedures, for instance, or any runbooks, text, and you want to expose this text to your agent, don't put them into the PostgreSQL as a plain text or whatever. It's better to convert this text to embeddings to actually enable agent to make this vector similarity search. So what if we are exposing SQL database to our agent? So here we have a very widely used pattern, which is called text-to-SQL. And it is one of the most common patterns for letting agent perform queries on operational database. And we have two very important rules again. First, your agent should know the schema of your database because it's good practice. It will allow your agent make uh, less queries to your database to find out actually how it works under the hood. And one more thing to keep in mind is usually with this approach, you don't give your agent permissions to, let's say, to write. Usually agents which are dealing with these types of data, they read. But in some cases, such as, let's say, support agent, which can perform let's say, rollbacks of orders. In some cases, agents are also able to write to a database as well. So, schema in prompt. You give large language model schema as a part of your tool description. So here in our tool description, you can see that we are providing the schema as a description, and we are not providing the real data because real data will be uh, read by the agent by performing the SQL query, but the structure, LLM knows the structure. What tables do we have in the database? What columns each table has? What types of data do we have in the columns, and so on. And then LLM will generate proper SQL queries using this schema. But what can we do with the SQL query which we got from large language model? Uh, we have to check that it is semantically correct, and we have to parse it. And again, we have to treat this SQL query as a non-secure or insecure code, as we did with the code which is generated by LLM in Python, for instance. And then we can execute this SQL query, and we have to execute using some least privilege account, least privilege user. So if your agent doesn't need to write over this database, don't give permission to the user which is used by this agent to write. Or you can use, let's say, table layer security. So give user permissions to exact tables which agent needs, and so on and so forth. So what we have to keep in mind about text to SQL, SQL query which is generated by LLM is insecure. You have to validate it, you have to parse it, you have to sanitize it, and only after that you have to run it. And even when you run it, you have to apply least privilege principle. Okay, opposite to that, vector search. And yeah, how it works. As I told you, vector search is done to find similar pieces of text. And let's say we have some text, some question, description, and run it through the embedding model. Embedding model is a type of model which converts your text to set of embeddings. Yeah, basically it's a set of numbers which are stored as a high dimensional vectors. And these vectors represents the meaning of the text. So embedding model is actually getting the meaning of your text, and then two similar pieces of text will produce actually similar vectors. So let's say vectors for water and Coca-Cola, I mean, they have quite similar vectors because both of them are liquid. We can drink them, and crucially, similar vectors are close together by the distance, how we call, or by similarity. So when we convert a bunch of data, a bunch of text to embeddings, then we can just load these embeddings to some database, vector database. And we embed every paragraph of text to this database. And after that, agent can not only answer your generic questions, but when you prompt your agent, it is able to read vector database to perform the search, which is named k-nearest, and embed this data from the vector database to prompt again, and only after that generate the answer, which will be more, let's say, relevant. It is a foundation of architecture pattern, which is called retrieval augmented generation. And with this pattern, your agent and your LLM is not trying to remember all the documentation that you have, but you are searching in this documentation on demand, on the fly, and you feed this documentation, pieces of this documentation to LLM when it really needs it. So when to use vector search and vector databases? When you see that you need some you need to answer questions over the unstructured content. Let's say documentation, FAQs, it might be code actually. You can convert your code to embeddings. It might be summaries of previous conversations with your customers. It might be, let's say, customer tickets, anywhere where you want to search not only by exact text, but also by similarity. Okay. What if you want to build your own vector store and create this RAG pipeline, but you don't know how? That's fine. In AWS, we have Bedrock knowledge bases, and this is the managed path to work with RAG. So in AWS platform, in AWS cloud, you can create Bedrock knowledge base. And this knowledge base is under the hood a vector store, and the whole pipeline of creating your documents into the embeddings, loading them to the vector store, and then retrieving them once you need. So you create Bedrock knowledge base, you point to some source of data. It might be S3, it might be your, let's say, internal wiki, Confluence, SharePoint. We have over than 30 connectors, and then Bedrock knowledge base will crawl over your source of data and will convert them to embeddings and will load to some vector store. We have OpenSearch as a vector store by default, but it is quite expensive. Be aware of that. It will cost you like $400 a month to have a Bedrock knowledge base on top of OpenSearch. But you can use S3 vectors, and it will cost you cents, maybe $2 per month, which is quite affordable. What let's say rivals do we have for the Bedrock knowledge bases? You can use Vertex AI search. It is a part of Google Cloud. We have yeah, you can use Azure AI search and a lot of other options. But as an employee of AWS, I would say that Bedrock knowledge bases are really good. Okay, how to actually work with your Bedrock knowledge base if you build your agent with Strengths SDK. So it's quite uh, easy. So here you have code snippet which actually runs this search on the knowledge base. So yeah, quite simple code. And this code will give you a bunch of responses, bunch of paragraphs of text, and then you can append these paragraphs of text to actual prompt to your LLM and get more relevant responses. All right. We are going to the end of our today's presentation, and third primitive, and it is some kind of a flip in concept itself, and it is a webhook. So we were talking about two other types of integrations where agent was acting. So agent was trying to reach out to external APIs to downstream systems. Agent was querying databases. It was fetching some external context. With webhooks, we are doing quite the opposite. The vault uh, reaches your agent. External systems are pushing events to your agent, and agent will respond to them. So what if your agent doesn't have any webhooks? Without webhooks, your agent is reactive. let's say your user types something, agent runs. Once the goal is fulfilled, agent sleeps. It is quite useful, but it is limited because user have to invoke the agent. But with webhooks, agent reacts to some external events. Let's say GitHub fires a webhook every time when PR is opened, and then review agent picks this PR, reviews the code, and writes some comments. Or PagerDuty fires alarm when something is down, and your on-call agent picks it up and makes root cause analysis and investigation, and your DevOps engineer is not getting alarm itself, it's getting they are getting uh, alarm and report how to fix this issue. Or Slack can send a webhook when you mention your bot in the chat. So with webhooks, your agent is no longer waiting for human prompt. It's watching that some events are happening in the real world. And with webhooks, your agents are very different. They are becoming autonomous. And when we are talking about agentic in a strong sense, we usually talk about agents which are exposed to real world by webhooks. But what actually are webhooks? Webhooks are endpoints which are accessible by external systems by, let's say, HTTP request, for instance, and then your agent is handling these requests. It might be not only HTTP, it might be a lot of different other types like WebSockets. It might be even just SMS. Uh, but overall, your agent is responding to some events. So your agent is becoming uh, event driven. So here we have a handler which is dealing with a classic webhook, which is sent over the web, not SMS, you can guess. And as a usual HTTP request, we are getting some header and body. In the header, we have to have some signature because usually we expose agents by webhooks with authentication. Yes, in some cases you might have no auth, and that's also fine if your agent is, uh, let's say, not harmful. But every agent, it uses LLM, and LLM inference, it costs money. So usually we want to have authentication on top of the webhook. So first step, when we get some post request to our webhook endpoint, and we don't want to trigger our agent as a first step. First of all, we want to check that authentication is passing. So we are verifying the signature, and only once the signature is verified and we are sure that this request is a proper one, we are invoking our agent by some queue. Okay, what if we want our agents to send webhooks? It also happens because webhooks are the way to communicate between systems by events, and it's quite a good way to build event-driven system. And let's say that your agent is invoked by Slack because you got a message, but you can actually send a message by another webhook to your Slack by this agent. And this is actually one of the most common outbound webhooks by agent to send some message to Slack or to Telegram. Uh, so idea is quite simple. You can treat your outbound webhook calls like any other API call. So you have to have, we can remember three, let's say, measures or layers of security and resiliency. And first is timeouts. The second is retries. And the third is keys of idempotency. And you also have to sign your requests if downstream system requires that, so you have to have some authentication. You can append some headers, or you can encrypt your request body and so on. So if we compare inbound and outbound webhooks, the mental model is the following. Inbound webhooks are waking your agent up. So your agent is usually idle when it doesn't have any tasks to perform, right? And uh, outbound webhooks are enabling your agent to communicate to the external world, like we did it with API calls. So with inbound webhook, your event flows into the agent, your agent reasons over it, makes some actions, invokes some tools, and after that it can send some outbound webhook, and it is event which is flowing out of your agent. And with these two types of integrations, humans can be just like observers, and we don't need any human middleware between the systems. Okay. Now we know about three types of integrations, about APIs, about databases, about webhooks, and how actually our agents are leveraging these three types of integrations. Here we have a simplified architecture diagram of customer support agent. So this agent is orchestrated by this lead agent, and it is actually a multi-agent system under the hood. And it is idle once in the yeah we start this agent, and unless we have some tickets or messages, this agent is idle. Uh, and this agent is woken up by inbound webhook. It could be, let's say, Slack message. It could be a Zendesk ticket. And once agent receives the webhook, it verifies the signature. It drops a message into the agent itself. So here we have actually the handler of the webhook, right? And agent picks up this message from the queue and starts reasoning. If we need to run some tools as a result of the reasoning on top of LLM, we can make API call. We can use some tools for that, and we can, for instance, check refund status on Stripe or track parcel on shipping downstream system. But what if the data which is required for this agent is exposed by local database? That's fine. Agent has schema of this database in prompt, and it can perform some select query on top of the SQL database. And agent always is steered by some policies, and you put the policies into the knowledge base, and you have set of tools to deal with this knowledge base or separate multiple knowledge bases, and you perform vector search over the knowledge bases. And once your agent has these types of integrations, it will be able to think, to reason, to perform real-world actions, and to reply to user with some reasonable data. But since it is an agent, we want to have not only reply to user, but we want it also to update some data. So we can provide one more API tool, which will go to, let's say, ticketing system and update the ticket. Let's say post some comment on top of this ticket. So agent is able to, it can run multiple tools multiple times. So if we have one box of API tool, one box of SQL tool, and one box of knowledge tool, it doesn't mean that agent will run them like only once. It can loop over the tools multiple times. It can call SQL, then realize that it needs, let's say, additional policy to figure out what is actual refund policy is, then call API to start this refund process, call one more API to write comment into the ticket, and your framework of harness, let's say strength agents in my case, is handling the loop. Okay, what pitfalls you can fall in? And let's talk about security and quality. First, it is prompt injection. Sometimes tools can be, let's say, poisoned, and as output, they can send prompt injection to your agent. Sometimes it happens. So if you are not controlling your tools, let's say remote MCP server, you have to treat this MCP server and tools which are exposed by it as insecure. So again, you have to have least privilege for your agent, and you have to sanitize all data which is coming from remote tools. Two tools pro. Uh, so it means that you can append so much tools to your agent that it will confuse these tools, because context window of your agent, it is very limited, and uh, you don't have to pollute your context, and your tools might, let's say, have some collisions, and different MCP servers can expose tools with the same naming but different descriptions, or with different names and the same description, and your large language model, which is backing the agent, it will be confused. So keep your number of tools like as less as you can. And three, it is a schema drift. So the schemas of data, they constantly evolve, and your tools might have some drift, like the downstream API might change, database might change the schema, uh, or tool description might be outdated because your software engineer, they changed the code base of the downstream system, and they changed the code base of the MCP tool, but they basically forgot to fix the docstring. So it is a good practice to actually generate tool schemas from live database introspection, and not use hand-maintained docs. And the solution is quite simple. You can use AI to keep your documentation up to date. What else? Cost and visibility. As I told you, every agent is performing a lot of large language model invocations, and each tool call is also making a large language model invocation. That means that if you trigger, let's say, 50 tool calls, your LLM will be invoked 100 times, and each invocation will cost you like some cents, but overall, you will be paying a couple of dollars per request. And imagine that you will scale out, and you will have not one user but hundreds or thousands, and you will be surprised by your bills in the end of the month. But how to limit our budgets? We have technical measures. So if you use, let's say, cloud providers, we usually have some budgeting tools. You can also set some number of maximum iterations over the tools. Let's say on each user request, your agent is allowed to perform not more than 20 requests of tools, or you can set some max limit of tokens per request. And these measures are quite effective. One more measure is circuit breaker. And what is it? Let's say that your agent is prompted by, let's say, undoable goal. undoable target, and it will be iterating over and over the tools, and it will try to solve this problem, and it actually can do it like infinitely. So you might have circuit breakers to break this loop when your agent starts looping over and over on the problem. All right. The second problem that is stated on this slide is observability. And actually, it is a very, let's say, foundational problem of trust, because we as a human beings, we trust to other humans or to result of work of other humans. So if I tell you that I trust my car, and I really do, that means that I not actually trust to this piece of metal, but I trust the people who build this car, right? The same applies to agents. If you want to trust your agent, you have to make it very transparent. We have foundational problem here that large language models, which are backing the agents, they are not transparent at all by their nature, because they are essentially a lot of layers, yeah, like black as a black box, and you cannot see which layers are activated, what exact neurons are activated, and how large language models reason under the hood before the decoding process. And here is a foundational problem, but we can make the agent, the harness, more transparent. So we can keep traces of thinking which are exposed by a large language model. We can log every tool call, and it is crucial to log every tool call, inputs, outputs, latency, error messages. Uh, what else? Uh, we have to log, let's say, how many tokens do we spend with each request, because it's crucial for FinOps. And yeah, we have some standards nowadays. For instance, OpenTelemetry is a framework which became industry standard, and strength agents support this standard out of the box. So you can use OpenTelemetry as well, and OpenTelemetry can integrate to, let's say, most of the observability tools. All right. Yeah. What can you do right now? Uh, you can start your, let's say, agentic AI project today. You can build your first API integration tool. Don't try to make a lot of different tools. One is enough, maybe two. You can start with very simple ones, such as get weather using Open Weather API, for instance. And try to use this tool with some large language model, let's say Claude or GPT, I don't know, whatever you want to. As a second step, you can add some database. Start with simple local SQLite, and make your agent read from this SQLite by implementing tool and text-to-SQL feature. Make sure that your agent is generating only select queries, not write queries or update queries. Also, you can try to add a webhook integration to your agent. So deploy it to some remote server, to some worker. It might be Lambda, it might be Bedrock Agent Core, it might be any runtime that you want to. And then try to wire your agent up with external system using, I don't know, Telegram, let's say. And step 4, try to wrap your set of tools that you have written for your agent into the single MCP server, deploy it somehow, and then connect it to a large language model, to your agent harness. With these steps, you will practice like all types of integrations, and then you will be able to create them by yourself. Okay, here I have a list of resources, and as I told you in the very beginning, I will share the PDF file. So you can just click on each link and uh, read some additional theory about that. And yes, that's it. All I wanted to say is thank you. Thanks for coming. Thanks for asking your questions. And if you do have any extra questions, I will be, yeah, happy to answer. Thanks a lot.
Thank you so much for your time and for putting this all information together. I think it will require some time from us on our side to digest all the information that you shared on us. Yeah, thank you so much. I don't know if anyone has questions, but yeah.
Yes,
Guys,
no?
yeah, no questions? Okay. I guess it was too much. Yeah, too much information in one
Yeah, sorry if
session.
it's
No, no, no,
overwhelming.
no, no. It's great. I think I was mentioning this before as well. These sessions are just the guidance, and we need to do more research. We just get the kind of the core information, but it's on our hands, and it's on us to do more research
Mhm.
to understand it better. So yeah, thank you so much for your time. Yeah, it was
Yeah,
very
thanks a
interesting.
lot.
Yeah.
I will share the PDF a bit later.
Yeah, sure thing. Yes.
So yeah,
Yeah. Thank you,
have a nice
guys.
evening. Ciao.
Thank you.